We want to find whether the given table represents a linear equation or function, a quadratic equation, or an exponential equation. So, to test using the linear, we will see if for every increase by by 1 for the x, we get the same increase for the y's. Right, so we know that increase happens by 1, 1 plus 1, 2, plus 1, 3. So we should test for the same increase, right? So let's see. What is the difference here? Negative 3 becomes negative 9. And the only way you do that if you subtract 6, right? So minus 6 is the difference. Minus 3 minus 6 is negative 9. Now, as you can see here, the difference is not going to be negative 6, even though the x increases by 1, right? Because the difference here is going to be negative 18. And negative 18 is not the same thing as negative 6. So this is not linear. Now, the second rule of thumb is to test. So quadratic is the last thing you want to think of when you know it's going to be 1 out of 3. First, you want to test the linear, then you want to test the exponential. So the exponential is going to be by checking whether the b factor satisfies all of these 3 numbers at least, right? And then we can also try out the fourth number. So how does the factor work? Basically, the factor is responsible of transforming the negative 3 into negative 9. And the same factor b will be responsible for transforming negative 9 into negative 27. And b, that factor, will be multiplied to each number to give you the next number, right? So let's find the b and test it for the subsequent pairs of numbers. We're going to use this pair first. So minus 3 times b should theoretically give us negative 9. So the b factor here is minus 9 divided by minus 3, 3, right? So if the b is equal to 3, we can test this value of b, the same factor, on this pair, on the next pair, which is minus 9 and minus 27. So let's see. So minus 9 times 3 should give us negative 27. Is it true? Absolutely, it is, right? So it works out. The next one, don't be tricked by this. The 4 is absent, but that's fine. That's fine. You can basically, to find at 5, you're going to use the factor of 3 twice, right? That's all it means. You're going to multiply the minus 27 2 times by 3 and not just once, because you're skipping one x value, right? So let's see. So we're going to get minus 27 times twice the 3. Two of these b factors should give us negative 243. Let's see if this is indeed true. Minus 27 times 3 is minus 81. Is minus 81 times 3 negative 243? Absolutely, right? Because we know minus 80 plus 1 times 3 is equal to minus 240, right? Distributing. And then minus 3. Right, which is minus 243. Bingo. Right, so we just discovered, unlike the previous exercise, that indeed we didn't skip the exponential this time. So we're going to say, yes, this is exponential, and that means it's not going to be quadratic. Okay, so now that it's exponential, let's find the values of b and a. Well, we already found the b value, which was 3. That's good. Right? So now let's find the a value, and then we'll successfully find the complete equation, exponential equation. So let's test the value, the first ordered pair, to find the value of a. So we're looking at this equation. Y is equal to ab to the x, right? So let's write b as the 3 because we already found it, to the x. So we're going to substitute 1 and negative 3 into the y and x here respectively. So minus 3 for the y should be equal to a times 3 raised to the x, which is 1 in that ordered pair. So as a result, this is minus 3 is equal to 3 to the 1 is 3. So we can just write 3a. Dividing both sides by 3 will give us the a value, right? So the a value is negative 1. Beautiful. So as a result, the equation that we need is y is equal to minus, we don't have to write the 1, we can just write minus, because minus automatically means that the 3 will multiply by -1, raised to the x power. Now, be careful that you see, since I didn't use the parentheses, the minus is not part of that power x, right? So x does not take care of the minus. If I've written, let's say, like this, that would be a wrong answer, right? Because the minus would be factored in for that power, right? But I didn't write it this way, so minus does not apply. Only 3 takes that power x, right? So this is the correct solution to this problem. This is the desired exponential function, and if you're doubtful about it, just check every single value. You will get the correct y for the respective x. So when x is 1, this is -3, right? Because 3 to the first power is 1, 3 to the first power is 3, so minus will give you -3. When you have 2, you will get 9, apply the negative, -9. When you have 3, you get 27, apply the negative outside of that power, -27. And then finally, apply the 5. 3 to the 5 is exactly 243. Apply the negative, bingo, -243. So I hope this was useful and helpful. Thanks so much for watching. See you in the next video.